Alright, I'm someone who enjoys doing plenty of things, specifically building things and tinkering with things and all the things, and you may be wondering just how I do the things, and it's best to use an example. Today I'll give you a quick rundown of how to build a head tracking robot that'll be quicker than you can say. First, find some inspiration. You can't really make an interesting thing without knowing what it is first. It can hit while you're in the middle of a lecture or mid-solo, but those are rare. Personally, pentagrams do the trick. Afterwards, you need to know what you're doing. Break the bot down into its components: camera moving motors, motion tracking sensor, transceivers, and build it up by parts in no particular order such that you're able to test them individually prior to incorporating them into a larger project where it is far harder to debug and far easier to lose your precious hard-earned sanity. You'll pick up spare parts as they pop up. There should be a camera down there. If it's not down there, check the couch. You saw it was in the couch. And if you're following along well, you'll wake up on top of the rest of your required supplies. By now, if you're not rolling in stray components, you're not a hobbyist, you're a filthy casual. After recovering from your tangents, you'll need to test your newly found camera. Solder some hobbyist-friendly color-coded wires to the camera's power leads. Use lighter colors for positive, darker colors for ground, and after carefully disassembling a toy drone, solder the leads directly to the volatile lithium polymer battery. It should work. Does it work? It should work. And now you can fly all around your house. Neat. Now you know that all you need for decent videos is a simple power supply. We can now move on. Pan tilt motors aren't complex. Your pan motor shakes his head no, your tilt motor shakes his head yes, and the resulting bot should be an indecisive, safe for impending singularity bot. Gather your hot glue and imagination and stick the two together. But now, you might ask yourself, you've got to figure out how to translate head movements to pan tilt angles. You started the project thinking that you just sent over the raw data from your spare accelerometer to the motors, but after several hours of trial and error, figured out that it doesn't quite work that way, because accelerometers don't work that way. So you imagine the sensor is a box with a ball suspended in the middle. When the box moves to the right, the ball slams into the left wall, and so on and so forth. But if you rotate the box around the ball doesn't hit any walls. That's why an accelerometer can't work alone. It measures linear motion, but it doesn't measure angular motion. Now you need to find a new type of sensor. Gyroscope accelerometer combos are cheap and widespread. Gyroscopes measure angular velocity, filling in the gaps left by accelerometers. However, you're still doomed. You tried to blindly apply the new raw data to the motors. Thus, it's now time to fall deep into the hole, where time has lost its meaning and existence is but a means to finding a hacky solution, because see, you didn't stop to think that gyroscopes don't give you readouts relative to the ground, instead giving you a readout of angular velocity relative to itself. Now you've burned through just over a week just trying to figure out the relationship between its local body rotations and the outside world. You'll know you're doing well when you start hallucinating rotating axes mid-lecture. You'll soon start looking for more help. Reach out to teachers and old forums to uncover a few hints before finally learning of different representations of orientation in three-dimensional space. There are Euler Angles and there are quaternions. Euler Angles are more intuitive, so you'll start deriving their interpretation instead. You can think of Euler Angles as consecutive rotations about an object, like if we take an object then rotate about its z or yaw or pan axis, shaking its head no, then rotate it about its new y or pitch or tilt axis, shaking its head yes, then finally rotate it about the new x or roll axis we've transformed it from its initial inertial frame to its relative body frame. However, Euler Angles have a few issues. You need to measure them in order or you'll end up with the wrong end result, and they deal with gimbal lock, which happens when your first axis and your last axis line up with each other, leaving the sensor readouts as the same. Mathematically speaking, the representation flips the frick out. Got it? Good. You figured out that you needed to integrate the angular velocity readouts to generate the rotational matrix, converting between body orientation and inertial orientation. In other words, you figured out how to undo all of the rotations that are being done to the sensor. Good job. Now we just need to test it. Good. The rest should be a relative breeze. Grab a cheap radio with a decent user base in case you screw up again, because you will screw up again. Steal another Arduino from a close friend and have the two Arduinos flirt with each other. As soon as you see the successfully steamy interchange, however, you stumble onto another issue. They can only communicate with packages of ones and zeros, while your angles consist of more than ones. Your angles are stored as floating point numbers, numbers with decimal points. In turn, you can't send them over as is. To solve the newfound problem, you could convert between floats and bytes, but there's a cleaner way. You can send over the actual bytes stored in the processor's memory. It'll be like sending over pieces of cereal instead of an entire box. It's still cereal in the end. Now, hold on, you don't know how to access byte components in the memory, nor do you know how to manipulate it. So instead of trying it out on the Arduino first, you'll work on the syntax in an online compiler in C, then translate it to Arduino. Does it work? Good. Now test it again. Again. Wait, did the camera break? Come on. Bad wire, right? Go ahead and resolder it. Now test it again and give it a weird off-putting name. Baby hit should do. And that's just one of my projects. Definitely one of my favorites, and still a work in progress, considering issues with driving orientation and the future goals of expanding it to an entire humanoid baby bot, but it's just one of them, each similar in their bumpy, fascinating, sleep-deprived, frustratingly satisfying process. Again, I like to build things and tinker with things and do all the things. I've written a two-dimensional Rubik's Cube because it seemed like a fun puzzle. I solved the Tower of Hanoi because I wanted to learn recursion. I've had fun. And I always will.